You can see my presentation?
Yes.
Okay, let's start. My name is Evgen Mirzlikin. I am PhD student at the National Aerospace University Haim. I will present topic open source technology stack for IoT, a case study for the renewable energy industry. So, in my report, I would like to cover the following aspects. Introduce the team involved in the research, motivation, goals, and tasks. Present a study on the use of open source software creating technology stack for IoT, describe some of the results, and draw conclusions and future steps. The research with my colleague Evgen Webeshka, PhD, associate professor of the National Aerospace University, Haim. So, motivation, goals, and tasks. In the industry, the world of industry control system has a long and successful history of software utilization and automation solutions. Although it is on not even possibility to imagine a modern industrial control system without software. Such software significantly differs from the one used of other fields. Such difference results from the following. Heavy dependencies and industrial automation vendor, considerable dependencies on the automation object, property of most solutions, and also the lack of method necessary to ensure innovation and interoperability, and complexity. Such excessive complexity and closeness lead to additional possible vulnerabilities. In contrast, industrial Internet of Things IoT brings open source software of the industry. Relevant studies have been analyzed, and most studies confirm that open source is central of modern industrial solutions, becoming a serious competitor to traditional proprietary solutions. The open source allows the use of free software different tasks, reducing development costs and risk, and as increasable flexibility and changing production environments, making complexity manageable, opening new opportunities for improved security, etc. It is also invited to complex open source technology stacks are still on the way widespread use in IoT, which makes this research direction promising. For the motivation, build a modern security technology stack for IoT. Motivation lead to these goals and tasks. Research possibility of open source software stack application of the industrial need with a particular for the security. Apply the technology stack for renewable energy industry, and present it is a case study. Analyze potential security improvement of software solution used in the industry. Modern market includes a considerable number of open source products that could be used as the purpose of IoT system. So the figure shows proposed open source technology stack with the main components and links between them. The following open source technology stack has been selected: Grafana, InfluxDB, Telegraph, and Node-RED were selected As a core tools, build a technology stack with the capabilities to satisfy requirements, compatibility between each other, widespread occurrence, necessary features, and data collection, processing and visualization, and availability of open source version. Every selected tool could be deployed and almost at any modern platform: Unix, Windows, Docker containers, and other. This simplifies deployment options and makes system for flexible. Communication between all IoT system components is security by utilization of HTTPS and basic or token authorization. Now let's look at each selected component in detail. InfluxDB is an open source purpose-built time series platform optimized for large datasets for both high read and write throughput. Therefore, suitable will for IoT data flows. It allows flexible configuration of data, returns, supports creation, and tasks to perform some operational data. And InfluxDB provides possibility of creating buckets with configurable retention policy. This allows store data as long as is required by its type. Another important feature provided by InfluxDB is the possibility to create tasks that are run as database level. Using task is possibility in down simple data, implement necessary aggregates, access to the storage that's been configured via API tokens with necessary options, particular buckets, particular operation type like read, write. We use Telegraph to collection the data. Telegraph is an open security tool intended to aggregate data using various communication protocol, change the incoming data with the process further, and then forward the processed data to consumers like time series datasets. Telegraph has plugin architecture with most of the IoT protocols, such as MQTT, Modbus, OPC, UA. It requires no external dependencies and need a minimal memory footprint. To configure Telegraph for data collection, processing, and forwarding, it is necessary to prepare in configuration file. This file is a text file that defines what plugins to enable, what settings to use, and Telegraph starts. For each Telegraph plugins, there is one set of configuration options. It would mention this Modbus protocol doesn't provide any built-in security mechanism. For such communication channel must be security by introduction of the additional security means, adding client IP addresses to the whitelist on the server, VPN usage, or others. Another problem being solved Telegraph is the data transmission of the time series database. This implemented by configuration the InfluxDB output plugin by specified access token, necessary bucket, and other. Telegraph supports TLC SSL certificates and access token can be specified in the configuration file. To manage control system on this backend in the proposed technology stack is implemented using Node-RED. Node-RED is an excellent IoT gateway deployment tool that always the developers for build complex IoT application in user-friendly environments. Its visual interface and extensive library of nodes and integrations simplify the development, testing, and deployment of IoT application. Advantages of the usage Node-RED on IoT gateway: it supports HTTP, MQTT, WebSocket, TCP, UTP protocols, which created great conventions for devices and communication with the cloud server. Necessary step is to configure Node-RED authorization, which is disabled by default, and enable HTTPS to ensure security. This being done, we provide setting in the Node-RED configuration file. As for visualization and observation, we use Grafana. During human-machine interface design stage, a set dashboards was created to provide information on the whole plan level, particular inventory level, etc. For example, as the inverter level, the following information is presented: reference data, operative data, limitation, number of broken strings, historical charts of all measure parameters, status history, button of inverter control. Dashboard data refresh rate can be changed by use via built-in Grafana capabilities. To make control secure, for each API call authorization and configured using based authorization approach. Header contains authorization key and credential encoded using base 64 encoding. Access to the backend is implemented via HTTPS. Payload contains information on an inverter to be controlled and required amount. Currencies of the payload is being verified at the backend side. Aside from single inverter control, batch control and power limitation control were almost implemented. For inverter batch control use can choose several inverters and issue some command follow them. As for power limitation control, user specified required limit, and it is being distributed proportionately between all inventories of this power plant. Limits specified by user further being verified to avoid situation of human error intended attacks. This we arrive to the following observers and conclusion. The example of an open source technology stack for IoT and was presented as will system utilizing and was discussed and analyzed. Aspect for of security configuration for all components we show. The obtained results allow drawn conclusion the possibility of the present open source technology stack are huge. The proposed approach can be used not only for renewable energy monitoring with easy scalability, but also as a learning material for students do this use of open source stack, easy deployment and low source of entry. This technology stack allows of more sophisticated security testing activates the traditional SCADA system, which typically acts black box for user. For the next research steps can cover the qualitative and quantitative security assessment of the proposed solutions using techniques reviewed in our previous work. Thank you very much for your attention. I will be happy to answer
Thank
any
you.
questions.
This is definitely significant results and contribution. And thank you for your report.